Good day, everyone. I am here today to discuss about hypothesis testing. So hypothesis testing is a decision-making process for evaluating claims about a population based on the characteristics of a sample purportedly coming from a population. So our first problem. A researcher used a developed problem-solving test to randomly select 50 grade 11 students. In this sample, the mean is equal to 80 and the standard deviation is equal to 10. The mean and the standard deviation of the population used were 75 and 15 respectively. Use the 95% confidence level. Our step 1 is to formulate the hypothesis and state the null hypothesis, which is HO, and the alternative hypothesis, which is H1 sub 1 or H sub A. So, in our given problem, our null hypothesis is mean equals to 75 and our alternative hypothesis is the mean equal to 75. Step 2. Choose a significance level for A and we will answer the question, is it two-tailed or one-tailed? What is the appropriate test statistics to be used? So our level of confidence is A equals to 1 minus 0.95 because 100% minus 95% is equal to 5% and turned into decimal, which will be 0.95. 1 minus 0.95 is equal to 0.05, which will be our level of confidence. Our alternative hypothesis is non-directional because it is two-tailed. Appropriate test statistics to be used is z-test because our standard deviation is known and it is equal to 15. But since our sample is greater than 30, then the appropriate test that will be used is z-test. Step 3. Establish the critical regions. Get the critical values from the test statistic table. So this will be our critical value of z. So since our level of significance is 0.05 and we have a two-tailed test, then our critical value of z is 1.96. And since it is two-tailed, it is either positive or negative. Step 4 is to compute the z value. So the formula we will be using is z equals the mean minus the population mean over the standard deviation of the mean. So let us first substitute the variables. So our mean is 80 minus the population mean, which is 75, over the standard deviation, which is 15. Square root of the sample. Then 80 minus 75 is 5 and 15 divided by the square root of 50 is 2.12, which will give us an answer of 2.36. Step 5 is to state the decision rule. This is to decide whether to accept or to reject the null hypothesis. So to reject the null hypothesis, if the computed test statistic is less than or equal to the negative critical value, or if the computed test statistic is greater than or equal to the positive critical value. This will be our graph. This is the critical value, positive and negative 1.96, and the middle, which will be the mean, and we will find where is our computed value. Our computed value is 2.36, which will be found here. Since it is under the shaded region, or which we call the critical region, then it is classified as a reject. Unless it will fall on the unshaded part, then we could accept the null hypothesis. So our null hypothesis is rejected. Since the computed value of z, which is 2.36, is within the critical region. Step 6 is to interpret the result. There is a significant difference between the sample mean and the population mean. since it is rejected. The sample belongs to a population that is above average, and that is 75. Our second problem: the owner of a factory that sells a particular bottled fruit juice claims that the average capacity of their product is 250 ml. To test the claim, a consumer group gets a sample of 100 bottles, calculates the capacity of each bottle, and then finds the mean capacity to be 248 ml. The standard deviation, S, is 5 ml, and to conduct a hypothesis test using A equals to 0.05. Is the claim true? Step 1. Our null hypothesis is mean equals to 250, and our alternative hypothesis is the mean less than 250. Step 2. Our significance level is A is equals to 0.05. Our alternative hypothesis is directional and it is one-tailed. Our standard deviation is known and it is equal to 5. But our sample is greater than 30, then the appropriate test statistics to be used is z-test. Step 3. Our critical value is negative 1.645 since we will be using the left side part of the graph. Our level of significance is 0.05 and it is one-tailed. That's why it is 1.645. Step 4. The formula that we will be using is mean minus the population mean over the standard deviation divided by the square root of n. To substitute the variables, 248 minus 250, that would be negative 2. Our standard deviation is 5 divided by the square root of 100, and that would be 0.5. To sum it up, it would be equal to negative 4. Step 5. This would be the graph, and negative 1.645 would be here, and we would shade the left side of it, and our computed z value is negative 4, which will be located here, and it is part of the shaded region. That's why we would reject the null hypothesis. HO is rejected since the computed value of z is within the critical region. Step 6. There is a significant difference between the sample mean and the population mean. The sample does not belong to the population whose mean is 250, so the claim is not true. And for our last example, a pH below 7.0 is acidic, while a pH above 7.0 is alkaline. This all refers to drinking water. A pH of 7.0 is neutral. A water treatment plant has a target pH of 8.0 based on 16 random samples. The mean and the standard deviation were 7.6 and 0.4. We will use a level of significance of 0.05. Step 1. Our null hypothesis is mean equals to 8.0, and alternative hypothesis is mean which is not equal to 8.0. Step 2. Our significance level is A equals to 0.05 since it is given, and our alternative hypothesis is non-directional and it is two-tailed. Since our sample is less than 30, the appropriate test statistic is t-test. Step 3. We will first find the DF. To find the degree of freedom, we should get the difference of the sample and 1. So our sample is 16 minus 1, which will be 15. And we will base this on the T table. So our A is 0.05 divided by 2, which will be 0.025. Our DF is 15. And based on the T table, we will find that this will be located at positive and negative 2.131. Step 4. Compute the t-value. The formula we will be using is the mean minus the population mean divided by standard deviation divided by the square root of n. Substitute the values. We have 7.6 minus 8 divided by 0.4 divided by the square root of 16. This will all result to negative 4. Step 5. So this will be our graph. Here is negative and positive 2.131, and our computed t-value is negative 4, and it falls under the shaded region. That is why we can reject the null hypothesis. So reject the null hypothesis since the computed t-value is within the critical region. Step 6. So our conclusion is there is a significant difference between the means. So that is all for now, guys. I hope you did learn something and you enjoyed. Thank you.